Now let's take a look at some illusions related to shading. So here's an interesting one, not necessarily related to shape frame shading per se. If you and I take a look at this, you see a large green circle, of course, but in the center you see this sort of fuzzy blue disk. And if you actually fixate, when your eye moves around, you'll continue to see the blue disk in the center. But if you fixate on one point, it doesn't have to be the center of this disk at all. You can just pick a point here, say, for instance. And at this point, you might want to freeze the video and watch this because it might take you a little bit of time. But if you fixate on one point, and then keep staring at that point, you'll find that this blue disk, the blue fuzzy disk in the center, just fades away, and you just end up seeing one green disk. This is an interesting thing because it turns out that the human visual system is not really measuring the brightness and color at each pixel independently. It's primarily looking for changes in brightness and color. So as your eye moves around, you continue to see the changes in the center, and therefore you continue to perceive this blue fuzzy area right here. But when your eye fixates at one point, essentially you cease to see the changes because the change from green to blue here is very, very slow. And all of a sudden you find that the blue disk, the blue fuzzy area just vanishes. And then there's this other thing that's related to shading. This is an illusion we talked about earlier, which is the checker shadow illusion due to Adelson. So in this case, you're looking at two patches, A and B here. And we can all agree that patch A appears to be made of darker material than patch B. However, if I show you only patch A and patch B, that is, I hide the rest of the scene, you find that patch A and patch B have exactly the same brightness. So what's going on here? You remember we talked about the fact that we like to assume that the entire scene is illuminated the same way. We do make that assumption. However, we are also able to, we as in humans, are also able to handle gradual changes in illumination. You can see in this case, you have a shadow right here, and there is a change in illumination over the entire scene. And our human visual system is able to figure out what that gradual change is. We're not looking at dramatic changes, but gradual changes. And then we compensate for the brightness values that we measure in the image using that gradual change. We normalize it in some ways. By doing so, we are able to figure out that this is actually made of darker material than this one right here. A is made of darker paint, say for instance, than B is, despite the fact that both of them actually produce the same absolute brightness values in the image. So we're doing some illumination filtering in order to perceive the properties, the material properties, or even the shapes of objects in the scene.